So now we look at the dot product, or what we call the scalar product of two vectors. So we look at the scalar product, or also called the dot product. And it's called the dot product because the way we write the vector is by using a dot. So if you have a vector A and a vector B, and we want to take their dot product, you put a dot in between, and that's a symbol that this is a dot product, and the result will come out to be something else, C, which is not a vector. That's why it's called a scalar product. So A dot B becomes a scalar. The definition of A dot B is that you take the magnitude of the first vector, you take the magnitude of the second vector, multiply them together, and take the cosine of the angle between them, and then A, B times cosine theta becomes the A dot B. And well, that's how we got the work, was F dot, the delta R, or delta X, or displacement. Now we look at some properties of the dot product. First, it's commutative, which means A dot B is the same as B dot A, and so you can use any order in dot product. And the second is that the dot product is distributive over addition, which means that if you have A dot of B plus C, so A, B, C are three vectors, you can add B plus C and then dot them with A, or you can dot A with B and then A dot C and add them together. So this is addition is distributive. It's a distribution. The dot product is distributive over addition. Now, as an example, let's take taking the dot product. We take a vector A, which is, let's say, like this, and the vector A is, I'll write them here, and another vector B, which is more like this. So the vector A is 20 units, whatever is the magnitude, let's say newtons, at 30 degrees. So this angle is 30 degrees. And the vector B is 10 units, let's again say newtons, at 150 degrees. So this angle is 150 degrees. Now, when we want to take A dot B, we would write it as A times B times cos theta. So what is theta? That is the angle between these two. So the angle between these two would be, if I redraw A at 30 and B at 150, the angle between these two, this angle, would be 150 minus 30 would be 120 degrees. So theta is 120 degrees. And then the A dot B would be the magnitude of A, which is 20, times the magnitude of B, which is 10, times the cosine of 120, which is negative 0.5. So that's 200 times 0.5 is 100 with a negative sign. So A dot B becomes minus 100. And so the dot product could be positive or negative, but it's not a vector, so it's just a number. Now, instead of writing the dot product in the vector as magnitude times the direction, the vector A could also have been written as an x component times I plus y component times j, and the vector B could have been written as bxi plus byj. And then when we take A dot B, we will write it as axi ayj, that's the A vector, and we dot it with the B vector. And now by using the distributive law, we can do the same thing here. We multiply the first term with both of these and the second term with both of these, so we'll get axi dot bxi, so that's the first with the first with the second, axi dot byj, and then the second with the first, ayj dot bxi, and the second with the second, ayj dot byj. Now ax and bx are numbers, so we can simply write it as ax bx, and this would now be I dot I plus ax by, the two numbers, and I dot j, and these two, ay bx j dot I, these are not multiplied together, they are dotted together, and ay by j dot j. So now let's look at these dot products, this one and this one. So I dot I would be the magnitude of the first one times the magnitude of the second one times the cosine of the angle between them, and because I and I are parallel, so the angle is 0 and cosine 0 is 1, so it's 1 times 1 times 1, so it's just a 1. The same would apply to j dot j, and therefore I dot I is the same as j dot j, which is the same as k dot k in 3 dimensions, and they would all be 1. Now the other terms, the I dot j terms, would be the magnitude of the first one times the magnitude of the second one times cosine of the angle between them, and I and j are 90 degrees apart. Cosine of 90 is 0, and therefore it's 0. And this gives us I dot j is the same as j dot I because it's commutative, and that would also be I dot k or k dot I, or the third combination jk and k dot j. They are all equal to 0. They're all vectors, so they would all add up to 0. And so this equation can be simplified. This would be 0, the I dot j, and this would be 0, and this would be 1, and this would be 1. And so this is simply ax bx plus ay by. So that's the ay by and the ax bx, the 1s, and these are all 0s. Now if we do the earlier example, this example, in terms of a and b, so if I write this out in terms of axi and ayj, then this will become 20 cosine 30, which is 17.32i, and okay, so this vector is 17i plus 10j, and this one would be 10 cosine 150, so that would be minus 8.66i plus 10j. So now let's do the a dot b using this method, and we can write a dot b as 17.32i plus 10j dot, that's I'm writing a dot b, and the b vector was minus 8.66i plus sorry, that's not a 10j, that's a 5j. Okay, so 8.66i plus 5j, and we would multiply the first with the first, which would be this term, and the second with the second, which would be this term. So it's going to be equal to 17.32 times negative of 8.66 plus 10 times 5, and this becomes this time this is 150, and 5 times negative 150 because of that minus, and that is a 50, so that adds up to minus 100, which is what we had earlier. Now, as the last thing here, we'll see that if you have two vectors here, and these vectors were at these angles, and we want to find this angle which we found here. So there's another way to do this by using the dot product, and we would say that A dot B is AB cos theta. Okay, these are the magnitudes because they don't have these things over them, and therefore cosine theta would be A dot B over A times B, the magnitudes. So let's use this to find the angle between the two vectors A and B. So cos theta is going to be A dot B, and A dot B is minus 100, and the magnitudes of A times B is, the magnitude of A was 20, the magnitude of B was 10, so it's going to be 20 times 10, which is 200, so it's going to be minus 1 over 2, and so theta is the cosine inverse of minus 0.5, which is 120 degrees. So you can find the angle. Now, in the case of the two-dimensional two vectors in x and y, it's pretty easy to find the angle. You can just find it this way. But if you have a vector A, which is something I plus something j plus something k, and then you have another vector B which is also three-dimensional, then it becomes very hard to find the angle between them, and this is the way in which the angle between those vectors can be found if they are in 3 dimensions. Okay.